So this is IT circular disk, and moment of inertia is IT, and this is rotating with angular velocity omega I. This is having IB and it is rotating with angular velocity 0. Both of them, when they are placed in contact with each other, so friction will act in this direction on the first, like the new one, and in the opposite direction for the initially rotating circular disk. So now, since friction is equal and opposite, so therefore the net torque of friction, the torque of friction is going to be 0. So since torque of friction is going to be 0, net torque is going to be 0, so therefore angular momentum will be conserved. So since angular momentum will be conserved, so therefore initial angular momentum is equal to final angular momentum. Now that means IT omega I should be equal to IT plus IB into omega F. Now both of them will start rotating with the same angular velocity, because if they are not rotating with the same angular velocity, then again friction will act, and again friction will reduce the one which is having more velocity and increase the one which is having less velocity. So therefore we have omega final is equal to IT omega I divided by IT plus IB. Now what is the energy loss due to friction by the initially rotating disk? So ideally we should do half IT omega initial square minus half IT omega final square. This is the energy lost by the rotating disk due to friction, and the energy gained by the the second circular disk of the moment of inertia IB due to friction. That friction is causing gain in energy in the disk which was not rotating initially. So therefore that gain is half into IB omega final whole square. So this is the net energy loss in like the first one. This is the net energy gained in the second one. Okay, so ideally the answer should be this, but this answer is not matching with any of the options. Okay, so therefore what we'll be doing is we will be finding the total energy loss due to friction. So the total energy loss due to friction will be half IT omega initial square minus half IT plus IB omega final whole square. Okay, so let's find this. So this is half IT omega is square minus half into IT plus IB omega final. What is the omega final square? This is IT square divided by IT plus IB whole square into omega initial square. So now this and this is gone, so therefore this becomes half of, take the denominator LCM, so half IT plus IB, which is IT square plus IB into IT minus IT square, and this is omega initial square. Gone. So this is equal to half into IT into IB divided by IT plus IB into omega initial whole square. So therefore the answer is going to be D. Thank you.